Welcome to AI, Government and the Future, a podcast by Corner Alliance. We explore the intersection of artificial intelligence, government and the future with your host, Alan Pentz. We work with government to create results. We ignite your agency's mission by helping you to design and implement high-impact and innovative federal programs in AI, broadband, cybersecurity, public safety, and more. Being a government ally is at the core of all we do. Introducing your host, Alan Pentz.
Today, I'm welcoming Prabhu Patil. He's a digital transformation executive with a remarkable career spanning over 3 decades. He's worn a lot of hats, working with defense R&D, serving in high-profile roles at IBM, EDS, and Siemens. And today, he's the founder and CEO of PROLIM, company that's focused on leveraging information technology and product lifecycle management to solve complex business challenges. He's also the managing director of PROLIM Ventures, where he mentors and invests in the next generation of innovators. So he's been doing lots of great stuff, and he's also on the board of directors for the Dallas Business Club and was Entrepreneur of the Year named by the SBA. So that's fantastic. Prabhu, welcome to the show. We're glad to have you here today.
Thank you, Alan. It was a great pleasure to be participating in this event today.
Great. What I'd love to start with is kind of getting a sense from you. You guys sounds like span multiple sectors from aerospace and defense, manufacturing, and some other areas. So looking first where we're seeing AI in aerospace and defense, where do you see the state of that now? And what are some of the most exciting things you're looking at there?
Sure. So AI is heavily leveraged in aerospace and defense industry, particularly in the design, development, and manufacturing of those aerospace vehicles, for example, to developing military equipment. In order to build any of these products, the customers use CAD/CAM software for computer design and for mechanical engineering, for electronics, and the product lifecycle management called PLM are the key solution elements they use to build these products. So the AI is playing an important role in designing and developing these products. Historically, when the design happens, the people or the experts get together and apply their knowledge to build those products. Whether it's a SpaceX building the space vehicle or a Lockheed Martin or any one of them. But now using the AI technology, the more and more customers are developing the product design and innovation. Second, it's simulation and prototyping. 3, optimization of manufacturing processes. 4, supply chain management. And then 5, and so on, quality control, predictive maintenance, product configurations, data analytics, and so on. When you start about the product design, developing a vehicle, whether it's a SpaceX vehicle or recently India landed on the moon, is the 4th country in the world. So to build that kind of a complex vehicle and simulating that entire thing, applying everybody's knowledge, taking that knowledge, building that knowledge bases, and these LLMs, the artificial intelligence can able to figure out the product design optimization, simulating those conditions, whether it is a stress or a heat or environmental conditions, and developing that product and go through n number of iterations. For example, think of landing on a moon or going on the space and landing on the sea. So those conditions you cannot practically simulate them. So you have to use those technologies to simulate those conditions, simulate how it's going to land, what is the stress, how is the impact, all those things can be done using AI, and more customers are going in that direction.
Interesting. So AI is really just a force multiplier in the current sort of product lifecycle that you see. So where is the data coming from to feed the models that optimize and help with that process?
That's a key point you brought up, Alan. So if you look at all this data is the key, and that knowledge and using that data and creating that knowledge models, LLMs we call, that is the key, the foundation for artificial intelligence. So the data exists today because if you look at any aerospace and defense industry, they have been doing this hundreds of years, and they're trying these different vehicles, launching, whether it is a military aircraft or equipment, whatnot. They have the data. Until now, the data has not been harnessed properly to build this, improve the innovation, innovate or develop better products because it is very complex. It's very hard to understand that data. Now, with the artificial intelligence, with the empowered is the computing power, you can harness the data, use that data that's already been collected over the years and applying and putting into their knowledge models, then developing using this AI techniques.
Interesting. So you mentioned LLM. So they're actually using LLMs in this process as one of the key technologies. So I've just seen Elon speak at a conference. And so he was talking about sort of Tesla being one of the leading AI companies that no one knows, right? Because they collect all this data from driving, but they don't seem to really turn it into an LLM. It seems to come through a different mechanism. So can you talk a little bit about how you use AI as an LLM and then maybe in other ways that aren't necessarily a language model?
The LLM is essential for building a language specific. So you are doing a particular typing a certain sentences, then you interpreting that natural language and digging into the models and providing the data. But in a specific cases like Tesla, very specific use cases already. For example, when they're driving on the road, they're continuously collecting that data, the vehicle performance, the objects that are flying in front of the vehicle, and how the drivers are maneuvering that vehicle, and how applying the brake or et cetera, et cetera. They're all being collected and being used. They are very, very specific use cases. Hence, you don't necessarily have to build an LLM for that case. We are working with another customer, automotive customer. They have built a very excellent applying AI to leverage for day-to-day use. For example, when you're going in a car, suddenly met with an accident. So somebody has to make a call, 911 call. If the driver is still active, they can make a call or press the on-start button or something else. So now it's this AI. Now, as soon as you sit down, Alan, you sit down into the car, the inbuilt cameras out there that will see you and say, hey, he's an Alan. They may not know your name, but they know your profile. Hey, this is age group of this age, and this is his profile, is a African American or Indian or white person, and this is the weight of that person who's driving this car. They already know that when you're going in. As soon as met with an accident, it suddenly make a call and saying, hey, this kind of person of this profile is going in this direction, met with an accident, boom, boom, boom. Already information is already passed. Or if there are more than one passenger, hey, there are 4 people sitting in this car of these profiles. It does know it's not only one person, there are more than one person sitting in that car and met with an accident. The second example is if you park the car in the parking lot, somebody hit the car, you went to your office or a grocery store, as soon as somebody hit your car, the car already knows, hey, this person or this particular car hit you. It records every minute of that and then send a 911 call. So there's a lot of AI being leveraged or very specific cases where you need a data but not necessarily have LLMs for that.
So you can't, in the future, you won't be able to hit the other car and just take off without leaving a note, I guess, right?
Correct. Because always somebody will be watching you.
That's right. That's, I think, what everybody's afraid of, right? One question that kind of occurred to me while you were just talking there, though, is as we privatize things like space exploration, with SpaceX and Blue Origin and others, increasingly that data is no longer going to be the property of the federal government, right? It's going to be the property of private companies because they're going to be the ones launching and knowing. So someone like NASA is not going to have as much access to the kind of data that they collected when they ran the programs themselves. And I know, like in the defense sector, Anduril is kind of trying to do something similar where they design systems wholly themselves and then provide them to the government rather than the traditional Lockheed, Northrop model. So did you see any implications about that? Is it like necessary change, or is it something you think government's going to have to be wary of?
Does impact a big way because of the all about security. As you launch the satellites or launch the vehicle, you are flying in the space and you are collecting all kinds of data, whether it is a geographical data or military related data, for example, where the locations of those assets or the bridges or the tower, you can collect all possible data. But again, it's end of the day, it's all about that could be impact the privacy. So here the government plays an important role. It has to be worried about. The government has to put those policies and processes in order to govern that data. Data governance is a very critical. Even inside the company, they're collecting lots of data, whether it's a retail industry, then you go to the grocery store, you're purchasing this and that, all kinds of stuff, or your healthcare thing, the lots of data being collected. But the government has already put in place a lot of data governance, privacy policies, and so on and so forth. When it comes to the aerospace, similarly, data needs to be governed. Hey, this particular data I can use for commercial purpose. This person, any sensitivity to the cybersecurity or defense related thing has to be governed using the policies. That's a challenge. How much you can control and how much you can allow for companies to innovate and thrive. That's a balance government has to do.
We've talked a couple of times on the show just about the fear of when you look at regulations like HIPAA, they've really almost been a hindrance, or GDPR is another, from the EU. They just seem to have been a hindrance to innovation. And one of the fears is that the government will have to regulate. It doesn't have much choice. But are we basically ending permissionless innovation because of the need to govern the data?
It's a balance between freedom that will thrive and help innovation. At the same time, the government to control the data so that it's not being misused by some third parties for whether it's a cyber crime or using the health data to target those people. So that's where the governance and privacy policies have to be continue to evolve. Again, government can apply this AI for this, continue to learn along the way using this machine learning to fine tune that program as opposed to sit in Washington and try to write these hundreds of pages of documents. So that the AI and ML will help to fine tune those programs.
Yes, I fear that the hundreds of pages of documents is our future, but I think the profession of the future is data lobbyist. So that'll be a key thing. So just switching a little bit from aerospace and defense, we're sort of at this moment in the US where you hear a lot about the government's making multiple investments in semiconductor manufacturing, other advanced manufacturing. We see a lot of reshoring happening. A lot of people are calling it an industrial renaissance, unlike anything we've seen since the early part of the 20th century. So I know you guys are very involved in smart manufacturing. So kind of give us a definition of what you think that really means and how does it play out in today's industrial economy?
So when it comes to industrial economy, if you really look at the smart manufacturing is about industrial automation, asset monitoring, energy efficiency, predictive maintenance, sustainable supply chains. In the smart manufacturing, starting from conceptual thinking to the product rolling out of the factory floor, the end-to-end from thinking to rollout, which we call a digital twin. And you design everything on a computer, a digital model, and then you have a physical model where you start manufacturing and rolling out of a factory. This digital twin has to come together in a sustainable way in order to continue to innovate and build better and smarter products. So when we have to do this, there's a heavy automation is going to evolve. And in order to be competitive in the world, like all those manufacturing jobs went to China, for example. So in order to, and the reason they all went because they're a low cost country, there are less regulations, and they can produce the product much lower cost. Now, in order to, with all this political debacle and continue to grow and innovate in North America, in the USA, so we're bringing all this manufacturing back, most of the customers bringing back to here. To bring them, it has to be more efficient, more automation when there is a lot of labor shortage or costly labor involved. So the robotics and robots and all started doing that for a while. But now in order to build much faster, much more efficient, because the customer's demand has increased. Every customer wants a different configuration. Whether I want to buy a car, I want to have very specific, this color, this brand, blah, blah. Or even if you want to have a Coke, for example, Pepsi, you want a very flavorable drinks everybody wants. Those different configurations require more complexity of the product development. And that requires a heavy smart manufacturing, applying all these technologies, not only robotics, but also AI and ML, learning along the way and applying to build those products. So again, the smart manufacturing is continuing to evolve, and particularly in the industry of chip shortage, where we have the supply chain issues, the smart manufacturing in America is going to continue to evolve and revolutionize the industry to be competitive in the world.
So it sounds like you are seeing, the stories are saying like a spike in demand for these kind of technologies here in the United States. Is that right? Like over the last couple of years?
Yeah. If you saw during the pandemic, we all felt the shortage of every product, whether you're buying a car or buying some house equipment, whatnot. Some of our customers who make doors and windows. If you place an order today, it will take 6 months to get a simple window or a door. So because of the supply chain, now if you want to hasten that process, the smart manufacturing is key.
Excellent. So, and what would your estimate of like, if, I don't know what it was, the 60% of our manufacturing was done in China before, and I'm making that figure up, I don't have the evidence, but like, what would your level of, like, how much of that has shifted to the United States or to nearby, like Mexico, or kind of like nearby shoring? Would you have an estimate of that?
I don't know exact estimation, but the trend is shifting, but how much is shifted is still not there, because this whole decision started during the pandemic. Certain things, for example, in automotive industry. So automotive industry, the major components are manufactured here in near shore, like Mexico or Canada. Whereas the underlying electronics chips, they're all in mainly China or around in those countries. So bringing those big chip manufacturing to North America, it takes time. It takes few years to build that plant. So that shift has not happened yet. So now the US is most of the customers making a China plus one strategy in order to quickly mobilize. It's not only just building a factory, but also all the supply chain and all the subcontractors working for them and the material, the resources around it. So I think it is gradually happening wherever it's industry by industry, it's varying.
And Ajay, I thought you made a good point there, and it's not that's coming in the exact same form it was before. It sounds like as we reshore, nearshore, we're also taking advantage of new technologies to then maybe not produce at the same one kind of car that gets mass produced in one way. We're using the technology to now do mass customization, sort of how you see that. And so this is sort of the trend in what I guess is called Industry 4.0 or Fourth Industrial Revolution. And so tell us a little bit about that. It sounds like it's bringing together, so we got a lot of buzzwords there, right? Industry 4.0, it's also the Internet of Things, it's also smart manufacturing, but that's sort of what the combination of cloud computing, analytics, AI, machine learning, are those sort of the core technologies you're seeing come together to do this?
Yeah, absolutely. So Industry 4.0, the revolution started maybe a few years ago. So where you're bringing the not only your smart manufacturing, but also leveraging the cloud. So without the cloud engagement, it cannot scale. For example, most of the customers, they want to do certain operations. They used to estimate what kind of capacity of the servers they need, the network they need, databases they need. Then they go take some time to do procure and keep it. Now, with the evolution of the cloud, it's available instantly, can configure and go. And if you want to expand in different countries and different part of the world, it's right there available. The Industry 4.0 is not only bringing the automation, but also accelerating using the cloud technologies, AI, ML, and low code platforms. The traditional way that you customers used to write a software coding using C++, Java, .NET, and so on, different traditional way, it used to take 6 months to a year to develop that, then it takes months to roll out and then sustain and support. As you can witness in the airports currently, we heard a few times that the airports are stopped because of their traffic control systems are age old. They could not respond. Now, how do you modernize those things? So using this low code platforms, you can start modernizing those applications and continue to evolve and apply with these low code platforms, accelerate the development, but also bring innovations and hook to this AI and ML to faster decision making process.
So how do you see, like, as a consumer, say, as we go farther into this industry 4.0 and deploy these technologies, how do you think it's going to show up to the consumer? Like, what's their future looking like? What's the vision for that of you?
Sure, because I think end of the day, the whole of Industry 4.0 is to help and produce faster, better products to the market. So given that notion, the consumers are, end of the day, are the beneficiaries because now they have more choices. They can have more personalized products and services they can buy by sitting in their comfort of their home. They can do research, they can design what they want, then they can place an order to get that product they want. The heavy that will help consumers have their personalized products and services, but also at a cost effective way. So that's what consumers will be benefited with this.
Yeah. And as far as so then I think one of the obvious fears is as these technology, we originally shipped a lot of production to China because of obviously regulations and some other things, but a lot of it was cheap labor, right? That's since changed to some extent. And, you see some stuff going to like Vietnam and other places, but it feels like as we reshore, we're not necessarily reshoring the jobs. So I guess the fear in the economy is that, AI takes everyone's job, right? So how do you see that playing out, particularly in manufacturing as we reshore?
There's a big fear about the AI will take away the jobs. If you really look back in the past history, when the industrial revolution started, and before that, people were always sitting and making those products. There was a huge labor required. And then this industrial revolution happened. Then after that, the invent of the internet and the robotics and all, more automation came into play. Did these technologies replace the human labor? The answer is yes, they did. But it's shifted. It shifted from, instead of I'm doing on the factory floor, hundreds of people assembling the car or an aeroplane, now there are few people are doing that. But what others are doing? They're all moved into the value chain. It shifted into different areas. Now, with the artificial intelligence, it is going to reduce more and more, whether it is a manufacturing space or baggage handling at the airport or the operation theater. Instead of having a bunch of doctors and nurses to do the operation now, with the robots and the AI, we can have less number of people doing that precise work. Does it displace people? The answer is yes. But how do you deal with it? But as this displacement happening, the need for knowledge workers is continue to evolve. More and more people are required. There are millions of jobs out there in the in the United States currently unfilled. But if you want to do the same thing what I was doing 10 years ago, I'll become jobless. But how can I transfer myself? That's where the government and the industries and the academia universities are partnering. They play an important role in upskilling these people to move into that. So we can continue to complain and crib about, I lost my job, but on the other hand, we can look at half glass empty and half glass full. Well, let me learn this and move on. It requires sometimes the people who have access to that information much easier for them, but people at the lower in the chain, they may have difficulty into transform. I think that's where the government and the academia can help to do that transition.
Yeah, that's what I was going to ask actually. Is like, so what do you see the government's role in this? Like, what could government do to really accelerate this transition? So obviously you just said, helping reskill lower skilled workers. Are there other things you think either you see government doing now or you really think they need to be doing to help make this transition to Industry 4.0?
The government plays, if you look at when the Industry 4.0, which is invented in the fourth industrial revolution, that's founded in Germany. That is came back with the partnership with the government, German government, and the commercial giants like Siemens and other companies brought together. So that industry and the government partnership is critical to upskill these folks. So the knowledge is a key. We all have to learn, continue to learn, improve that knowledge. Even in our company, we call 4 legs of the stool. The first leg is the knowledge. If you don't have the knowledge, stop and learn. So if you have knowledge, you have a confidence. If there's a second leg, if you have confidence, you will execute. That's the third leg. And if you execute successfully, earn the trust. That's the fourth leg of a stool. So similarly, all these folks, government and the academia, whether it's a community college or high school or wherever, change the curriculum and have these more adult programs to upskill those folks. So we do a lot of them whenever we conduct a lot of training at PROLIM. Whenever we invite the public to attend some of this training at free of cost so that they can learn. Particularly, we are focusing on the ex-military veterans where they serve the country, but we offer them training free of cost to upskill.
That's great. Yeah, I do think that there's a real thought process the government needs to go through where, we obviously spend a lot of money on education, especially post-secondary, and we have a very good community college network, but and we have a great research network in the universities, but a lot of the support that goes out in student loans or other things, like, is it targeted to the jobs that we really need people to be doing in this next generation? And it feels like there's kind of a mismatch there where the government could really put its resources to help people get these kind of jobs that they're going to need.
Yeah, absolutely. There's a big gap there. The universities and community colleges, they're producing the future workers. So the focus is about what about the existing workers, particularly at the lower in the community or lower income folks, right? They don't have time. If they need to continue to work to make their money and meet their livelihood. At the same time, they need to equip themselves, to upgrade themselves to ready for these new technologies. So there is a gap. So how do we handle it? It's a handshake. The folks also have to try, spend their time every day or once a week, spend their time to learn what's going on in the industry and upskill themselves. At the same time, the government or the cities or the communities they live, they also have an important role in conducting these educational seminars. For example, you are doing right now exactly the same thing. You are conducting the podcast to educate the community who can listen, and that if it transpires to at least one or two people, I think we did our job. So that's the continuous partnership of the government, the communities, and the educational institutes, plus the companies.
That's a great point. I mean, one of the reasons I started this podcast was I just feel like the entire approach we have to policy, regulation too, but policy in general is very, very 20th century driven, even from the way we run our grant programs to the way we run educational support. We have to have sort of that. I think we had a big revolution in the late 50s and 60s on STEM education following Sputnik, and kind of feels like we need to have another moment like that where it really shifts our priorities to understand what's coming next, because the current way we're doing it is set up to support a system that is becoming increasingly irrelevant in my mind. Hopefully we do a little good. And you mentioned baggage handling. So do you think they can get my bags from the plane at Dulles in less than 45 minutes? Because that I would do anything for. When I come in at 11 o'clock at night, I'm like, oh, where are these bags? Well, excellent. Thank you so much for coming on today. I think it's a huge topic. I mean, our government is investing tens and hundreds of billions of dollars into, obviously aerospace and defense, but also advanced manufacturing. And it's kind of the theme of the 2020s, I think. So it's great to hear some of the technology behind it and some of the things we need to be doing. And, I just really thank you for sharing that and look forward to seeing what you guys do in the future.
Yes, thank you, Alan. Thanks for the opportunity.
AI, Government and the Future is brought to you by Corner Alliance. To find out more about Corner Alliance and how we work with government to create results, visit our website at corneralliance.com. And then make sure to search for AI Government Future in Apple Podcasts, Spotify and Google Podcasts, or anywhere else podcasts are found. And click subscribe so you don't miss any future episodes. On behalf of the team here at Corner Alliance, thanks for listening.